Have you ever wondered how your data packets find their way in a network? That's what we're exploring today. Picture this: you're sending a message across the globe and it magically appears on your friend's screen in a blink. How does this happen? Well, it doesn't involve magic, but it does involve some pretty clever technology. In a nutshell, that's what network switching is all about. It's a fundamental process that guides data from one point to another within a network. Now, if you're pursuing a career in networking or preparing for your CCNA exams, understanding these concepts is crucial. Not only will it help you comprehend how networks function, but it will also make you a better troubleshooter. It's like being a detective, but instead of solving crimes, you're resolving network issues. So, are you ready to dive into the world of switching concepts? Let's get started. First off, let's talk about MAC learning and aging, two key processes in switching. But what exactly do these terms mean? Well, let's dive in and demystify them. Let's start with MAC learning. When a switch is powered on, it doesn't know any MAC addresses. It's like a newborn, eager to learn about its surroundings. As frames pass through the switch, it learns. It takes note of the source MAC address of each frame and the interface it arrived on. The switch then stores this information in its MAC address table. This process is what we call MAC learning. Now imagine you're that switch. You're learning and storing all these MAC addresses, but your memory isn't infinite. Over time, some addresses become less relevant. Maybe a device has been disconnected or it's moved to a different interface. That's where aging comes in. Aging is the process of managing the MAC address table by removing old entries. Each entry in the MAC address table has a timer. This timer typically starts at 5 minutes and counts down. If the switch receives a frame with the same source MAC address before the timer hits 0, it resets the timer back to 5 minutes. In other words, it refreshes the entry. But what if the timer runs out? The switch assumes that the device is no longer reachable or relevant, and it removes the MAC address from the table. This process is called aging. These two processes, MAC learning and aging, work together to keep the switch's MAC address table up to date. They ensure that the switch knows where to send frames, improving network efficiency and speed. So, MAC learning and aging are essential for efficient data transmission. But what happens after the switch learns the MAC addresses? Let's find out. So, the switch has learned the MAC addresses. Now, it's time for frame switching. In the grand symphony of data communication, frame switching is the conductor, ensuring that each piece of data or frame reaches its intended destination. To do this, a switch uses the MAC addresses it has learned. This process is a bit like a postman delivering mail to the correct addresses in a neighborhood. Let's break this down a bit. When a data frame arrives at a switch, the switch examines the frame's destination MAC address. It then looks up this address in its MAC address table. This table is a bit like a switch's address book, holding the MAC addresses of all devices connected to it. The MAC address table tells the switch which port is connected to the device with the destination MAC address. The switch then forwards the frame out of this port, and voila, the frame is on its way to its destination. Now, this might seem like a simple process, but it's actually pretty ingenious. By using the MAC address table, the switch ensures that data frames are only sent to the devices that need them. This reduces network congestion and increases efficiency, making sure that our data highway stays clear and our information gets where it needs to go. The role of the MAC address table in frame switching cannot be overstated. It's the switch's guide, its map to the network. Without it, the switch would be like a postman without an address book, blindly trying to deliver mail. Remember, the switch builds this table by learning the MAC addresses of devices connected to it. So, the MAC learning we discussed earlier is a crucial part of frame switching. Frame switching ensures that our data reaches the right destination. But what if the switch doesn't know the destination? That's where flooding comes in. So, we've come across a situation where the switch doesn't know the destination. What happens now? The answer is flooding. Imagine you're in a room full of people, trying to find someone but you don't know what they look like. What would you do? You'd probably call out their name, right, hoping that they'd hear you and respond. That's exactly what a switch does when it encounters a situation where it doesn't know the destination MAC address. It resorts to a method known as flooding. Flooding, in the world of networking, is when a switch broadcasts the data frame to all its ports, except the one it received the frame on. It's the switch's way of calling out in the crowd. It sends the message out to all connected devices, hoping that the right one will pick it up and respond. Now you might think, isn't that a bit inefficient? And you'd be right. Flooding is like using a megaphone in a library. It doesn't discriminate, and it can cause unnecessary network traffic. It's not the most elegant solution, but sometimes it's the only one the switch has. On the upside, flooding does ensure that the message reaches its intended recipient even if the switch doesn't know where they are. It's a bit like throwing a wide net. You might catch a lot of fish you don't need, but you'll certainly catch the one you do. However, just like shouting in a crowded room can annoy people, flooding can cause problems. It can lead to broadcast storms, where data frames circulate in the network endlessly, hogging bandwidth and slowing down the entire network. It's a bit like a traffic jam on the information highway. But don't worry, switches are smart. They learn from every data frame that passes through them, and over time, they build up a MAC address table. This table helps them to route data more efficiently, reducing the need for flooding. Flooding can be both a savior and a problem depending on the situation, which brings us to our final topic, MAC address tables. Finally, let's talk about an essential tool for switches, the MAC address table. This table is a crucial component in the operation of a switch, serving as a kind of switchboard operator that directs traffic within a network. To understand the MAC address table, first, we need to understand what a MAC address is. Every device connected to a network has a unique identifier known as a MAC address. This is like the device's name tag in the network, allowing other devices to identify it. The MAC address table is essentially a list that the switch maintains. This list contains MAC addresses and the corresponding ports to which these addresses are connected. The switch uses this table to learn and remember where each device is located on the network, enabling it to efficiently direct data packets to their intended destinations. When a data packet arrives at the switch checks the table to find out which port it needs to send the packet to. If the MAC address of the destination device is not in the table, the switch uses a process called flooding, where it sends the packet to all ports except the one it came from. Once the intended device responds, the switch adds its MAC address and corresponding port to the table. As for aging, the switch doesn't keep MAC addresses in its table forever. It assigns a timer to each MAC address it learns. If a certain period passes without any packets from a particular MAC address, the switch removes it from the table. This mechanism keeps the table updated and avoids clutter with redundant or unnecessary entries. The MAC address table plays a crucial role in frame switching too. When the switch needs to forward a frame, it looks at the destination MAC address in the frame's header and checks its table to find out which port to send the frame to. So the MAC address table is like the switch's personal guide, helping it navigate the network. That was a lot of information, wasn't it? Let's do a quick recap. We began our journey by delving into the essentials of switching concepts, understanding how these technological marvels intelligently route data across networks. We then moved on to MAC learning and aging, exploring how switches learn network locations and handle outdated information. Our journey then took us into the realm of frame switching, where we learned about the efficient and effective data transmission process switches employ. Following this, we dove into the intriguing world of flooding, a methodology switches use when they are unsure where to send data. Finally, we delved into the intricacies of MAC address tables, the switch's memory that keeps track of where to send data. This has been a comprehensive look at the backbone of network data transmission. And with that, we've covered the basics of switching concepts. Remember, these are the building blocks for understanding more complex network processes. Keep exploring and you'll master the world of networking in no time.